So we just finished talking about circles. Now we're going to talk about parabolas. And I know we've talked about these before, but we're going to do it again in a slightly different way. So a parabola is the collection of all points P in the plane that are the same distance from a fixed point F as they are from a fixed line D. The fixed point F is what we call the focus of the parabola, and the line D is what we call the directrix. So as a result, the parabola is the set of all points P for which the distance from the focus to the parabola, to the point P, is the same as the distance from that point P to the directrix. There's a line that goes through the focus F and is perpendicular, meaning it makes a right angle to the directrix, and that is what we call our axis of symmetry. This is the same axis of symmetry we talked about with parabolas before. And the point of intersection of the parabola with the axis is the vertex. So what do we have here? Let's make some colors. So the two distances that are the same are this distance and this distance. They always have to be the same. The focus is right here, that blue spot. The directrix is this green line here. The axis of symmetry is, the axis of symmetry is right down the middle here. And this supposed to be lavender that looks gray. And the last thing we need is the vertex. And everybody should realize that the vertex is, trying to find a good color here. There is no good color. Maybe I'll have to use orange. So the vertex is right here. So that's our vertex. Now, before we go on, I want to show you a little demonstration of how this works. So this is on a website called GeoGebra, and you can drag the point P around and see what happens to the distances between things. So, actually I lied. You take M and you drag it. So if I drag M along the directrix, you can see no matter what happens when M gets bigger, the distance between when the distance between M and P gets bigger, so does the distance between P and F. And as it gets smaller, and they're always exactly the same. So as I just drag this along here, you can see how my parabola gets made because it's putting in little dots everywhere I go. So that's how making a parabola works. I just wanted to show you that that's what happens. Okay. So the other important thing to know is that From the vertex to the focus, that distance is A, and from the vertex to the directrix, that distance is also A. And we'll talk about how to find those A's here in a minute. Anyway, that is the basics of how these parabolas are made more algebraically by measuring distances, as opposed to how we looked at geometrically in the introduction video. So there are 4 types of parabolas we can do this way. The first type opens up, and it has the equation x minus h squared equals 4a times the quantity y minus k. And just so we know, hk is the vertex, and remember a is the distance from the focus to the vertex, or the distance from the vertex to the directrix, because they're the same. For a parabola that opens down, it's almost identical, except for one thing. Instead of a positive 4a, we have a negative 4a. But again, hk is the vertex, and a is still the distance from either the directrix to the vertex or the vertex to the focus. These two are functions, right? Because they would pass the vertical line test. So if they open up and down, they are functions. What happens if they open right and left? This is new. We didn't have these before when we were talking about parabolas. These, of course, are not functions because they fail the vertical line test. Their equations are similar to the other ones, but the x's and the y's are reversed. So this time we have y minus k squared equals 4a times x minus h. That's if it opens to the right. And again, a is the distance from the focus to the vertex, or from the directrix to the focus. And if it opens to the left, it's exactly the same thing, except we have a negative 4a instead of a positive 4a. And again, still, a is the distance from the focus to the vertex or the focus to the directrix. So that covers the basic formulas. We'll start doing some actual example problems in the next video.